Hello and welcome to the day 6 lecture for our Upward Bound Integrated Math 2 class. What I want to look at today is some stuff about polynomials. And in talking about polynomials, there's some things that we're going to have to get out of the way, and then we'll get to some of the more common stuff that's done. So let's just get started here. For some definitions, we have a term, or we might say terms, are building blocks of polynomials. They can consist of a sign, a coefficient, a variable, and an exponent on the variable. So things like terms would be, if we were talking about terms, a single term might be something like, let's say, negative 4x to the third power. Okay, that would be a term. Now, the problem with trying to define terms is it's kind of dependent on what a polynomial is. But a polynomial, it comes from the Greek language, poly meaning many. But we say, well, so sorry, polynomial, poly meaning many, and nomial just standing for term. So a polynomial is let's say that it's a mathematical expression made up of, I'm going to say, many terms. It doesn't have to be many, but that's the idea. That's what the word actually means. It comes from the two root words of poly and nomial. So it's a mathematical expression made up of many terms. The standard form of a polynomial is dependent on, it's just a different way to write a polynomial, but it's dependent on the order of the exponent variable combinations. Order of the exponent variable combinations in a descending manner. So if I had, and we'll look at several examples of this, but if I had a polynomial that, let's stick with this one, and let's say minus 2x squared plus 5x. And in fact, I want to write that a different way to start. Come on, give me a bigger eraser here. Stop wasting my time. If I were to write this way, that would be the same thing that I tried to just write a second ago. But notice that I have this x, and this x is actually, like we said before, to the first power. And with that being the first thing, it's not in standard form because I don't have the highest power of x coming first. So I would actually have to take this and move it over here, which I can do. My rules of algebra will let me do that. I just have to know that it's a positive 5x. But moving that to the end now puts my exponents on my variables in descending order, and that's kind of the marquee requirement for standard form of a polynomial. Okay? And I'm going to go ahead and say that's it for the hard definitions. The next one says the degree of a polynomial is the highest power of the variable. So the highest power that you have in your polynomial. In this case, my highest power is 3. So putting it in standard form makes this easy to find because all you have to do is you have to look at your first exponent, and that's going to give you your degree. And then leading coefficient is the number multiplied by the, I'm going to say highest powered exponent. I'm sorry, highest powered variable. So it's the number that's in front of the variable that has the highest power. Again, putting this in standard form really just means you're looking for the first number. If you go through the work to put a polynomial in standard form, that just means, again, having my exponents in descending order. All I have to do for degree is look at the first exponent, and all I have to do for leading coefficient is look at the first number being multiplied by that variable. Okay. Now, in doing this, we do have kind of our first thing that we're looking at today, and that first thing we're looking at today is called classifying polynomials. In other words, we're looking at how to name polynomials. So you could say that this is the same as naming polynomials, because it's a nice thing to be able to have a common language with somebody when you're talking about the same thing, to be able to say it in the right way. And these different things come into play when you're talking about how to name a polynomial, and realistically it can tell you the most information about it. So when I'm naming by degree, I could have a degree of 0, 1, 2, 3, or even bigger, and I'll classify that in its own category. And so whenever we classify polynomials, we do it by degree and we do it by number of terms. We do both of those. Again, the degree is the highest exponent. The number of terms, for that I kind of think about putting every term in a box. And then really what I'm talking about is how many boxes do I have. Okay, in this one I have 3. And then for number of terms, we have 3 specific names, and then we have our general name for anything more than 4. Sorry, 4 or more. So that's as far. There are other names. We're going to group all those other names together for our sake. So if the degree is 0, that means the highest exponent on the variable x is 0, meaning you wouldn't write it. It would be something like 5. Okay, that would be your polynomial. It only has one term, but it has one term and it has no variables, but that makes it constant. Something that's linear might look like 2x minus 7. That would be linear. Quadratic would have an x squared, and cubic would have x to the third. If we get anything with a 4th power or higher, we would just say, I'm going to generalize it with the letter n, and we would say an nth degree. So if that number was 7, if the degree was 7, you would say a 7th degree polynomial. Okay? That just saves us from learning a bunch of names. There are pretty specific names for a lot of these. I just don't want to test, can we memorize names? I want to be able to name them so that we can talk about them and then move on. Then by number of terms, if there's only one thing, like say there was 7x, we would call that a monomial. In fact, we would call it linear because it has an x. That would be a linear monomial. If there were 2 terms, like say I had 3x squared minus 5, that would be a binomial. It has 2 terms. And this one would actually be a quadratic binomial because of the x squared. The degree on this is 2, so it's quadratic. And then if a trinomial would have 3 terms, so kind of like our example up here, has 3 blocks. So there's 3 terms, and it would be a trinomial. And then if we run into something with 4 or more terms, we would just say with, it's a whatever degree polynomial with n terms. Again, n being that number that's more than 4. Okay? So I don't want us to learn a bunch of names that are useless, but it's okay to learn a couple of the names. You can do a little bit of memorization. Or just have this page in front of you when you're trying to name polynomials. So for the first one, this does say to write it in standard form, then classify it by degree and number of terms, and identify the leading coefficient. So there's kind of 4 things we have to do. First off, to write it in standard form, I notice that these two are just in the wrong order. Okay, I want to start with my x to the 3rd power, not with my x to the 2nd. So I'll just switch the order there. I have to make sure I drag that negative sign with me for the negative 4x squared, and then plus 3 on the end. So classifying it by degree, the degree is 3, so that's cubic. We would say that this is a, we would say that this is a cubic. Let me kind of get it out of the way. How many terms are there? There's 3 blocks, so there's 3 terms, so it's a trinomial. And then for the leading coefficient, the number that's being multiplied by x cubed is just a 1. So it's a cubic trinomial with leading coefficient 1. For the second one, again, I want to start with my x cubed, so I need to bring that in front. So 15x cubed plus x. So if we were to give this a name, again it's cubic because the highest power is 3. This time there's only 2 terms, so we would say cubic binomial. And then the leading coefficient is 15 this time. Okay. This next one is in standard form. It starts with the highest power of x, then the one after that is lower than that, and even lower on the last one. So what do we call this one? The highest power of x is 2, so that's quadratic. There are 3 terms, so it's a trinomial. And the leading coefficient is -7. Okay, the first number we see in our string of things is a -7. For the next one, what we kind of need to start with, we actually have these 2 things here that are like terms, so we should simplify those like terms. So 19x cubed plus 4x plus 3. Okay, so even though it started with 4 terms, this thing really only has 3 terms when you simplify it. So it is, now it's in standard form, so we're good there. It is again cubic because the highest power is 3. And again, it's a trinomial because there's 3 terms. And the leading coefficient is 19. The number that's being multiplied by x is 19. All right. The next one here, we have these 2 out of order, so we're going to have to drag that negative with the 13x squared, and then drag the positive with the 4x, and minus 11. And so our name here, the degree is 2, There's 3 terms, leading coefficient 13. So degree 2 means quadratic. If I could spell, that would be awesome. Quadratic trinomial, leading coefficient is negative 13. Okay. The last one here, again, it needs to be reordered. I need it to be negative 42x squared plus 13. So when we go to naming this, it has 2 terms, and the highest power is 2. So it's a quadratic binomial with a leading coefficient equal to negative 42. Okay. So again, those names are important. It's important that you can name them, and that is something that I'm going to ask you to do. Okay. Now on to the math involved with polynomials. Today we're going to talk about adding, subtracting, and multiplying. We're not going to talk about dividing polynomials. I'm going to leave that for a later class because it actually is a pretty complex process. Now, when we add and subtract polynomials, it really turns into just combining like terms. So that's kind of a big note that I would want to put here. Kind of a big key to this is I want to combine like terms. And I'll say maybe distribute a negative 1. So in the event that I'm subtracting, I'm going to distribute a negative 1. But in any addition problem, even though there's parentheses here, they don't mean anything. Okay? If I were to look at what this equals, I have a 3x cubed. I typically try to put it in standard form because I like it. It makes sense. I'm starting with the highest power of x and then working my way down. And if you need to, you can cancel them out after you write them, just to make sure that you've covered everything. And then I have an x squared, so I'll go ahead and write that. So plus x squared. And then for my x's, I have a negative 4x and a negative 3x, so that's negative 7x. And I've taken care of those ones. And then I have a positive 3 and a negative 5, so that's negative 2. And I've taken care of those ones. Everything's accounted for. This is my answer. I don't need you to name these, just the naming when I'm asking you to name them. Otherwise, just do what it's asking you to do. Here it's asking us to add and subtract. So on this next one here, I do notice it's a subtraction, so I'm going to go through and distribute a negative and get rid of my parentheses, because if I can get rid of parentheses, that's going to make life easier. Maybe not totally easy, but easier. So this will be negative 2x squared minus x plus 1. Another way to do this instead of distributing would just be to think, whenever I have a like term in the second one, I see this as negative x squared minus 2x squared. That's another way you can do it. I don't typically like that way, though. It gets a little bit confusing to remember to do that. Here, I just think about combining like terms. So I have negative x squared and negative 2x squared. That's going to be a negative 3x squared. A 3x and a minus 1x, so that'll be plus 2x. And then a negative 4 and a positive 1 will give me a negative 3. Okay, go ahead and pause the video and try the other 2 problems. Okay, hopefully you had a chance to take care of those 2 problems. In the first one, I noticed that I had so I went through and distributed the negative, but I noticed I had a negative 3x squared and a negative x squared. and then I had an x and an 8x. Combine those to give me 9x, and lastly, positive 8 and negative 4 to give me positive 4. In the second one, I had a 5x cubed, so I just rewrote it without the parentheses and turning that plus and negative 3x into negative 3x squared into minus 3x squared. But I did notice that I had a 5x cubed that I didn't have a match for. Same with a negative 3x squared. Didn't have a match for that either. My x's, I did have a match for, a negative 6 and a negative 2. And then my numbers I also had matches for. So just combine those like terms and you're good to go. In the next part, we're going to look at multiplication. Now, I had this kind of broke down into some different ways to look at it. But it all kind of comes down to distributive property. That's always a way that will work. Sometimes we have some shortcuts that can also work. But if I have a monomial or a single thing on the outside and any version of a polynomial, here I have a binomial on the inside. If I have a monomial times anything, I just get to use distributive property. And it's actually pretty short and easy. I don't have any examples of that because we've already worked on that, right? We know that if I have 5x, and it could be even 5x and then 4x squared minus 3x plus 10, you know, I could do that. All I have to do is distribute the 5x to everything, giving me 20x cubed negative 15x squared and plus 50x. Okay? Again, just distributive property. Make it work for you. Make it easy. Okay? Next part I'm going to look at when I have a binomial times a binomial. Now, there's two ways to do it. I want to talk about where our shortcut method comes from. But the first idea is that I want to multiply kind of the overwhelming idea that I want to talk about and then show how we can do it easier is I want to take everything in the first, so everything individually in the first set of parentheses and multiply it by the second set of parentheses. And then I want to take, so I've taken the A, so I want to take A and multiply it by C plus D. Wow. Sorry, I tried to go a little too fast there. So I want to take A and multiply it by C plus D. And then I want to take B and multiply it by C plus D. And then I'll notice that after that I will have to distribute the A and distribute the B, but I'm not going to write that out. We'll just look at it here. So for the first one, I have x minus 2 times x plus 3. I'm going to take the x and multiply it by the second set of parentheses. So x times x plus 3. And then I'm going to take this negative 2 and multiply it by the x plus 3. Okay, so I get x times x, which is x squared, x times 3, which is 3x, negative 2 times x, and negative 2 times 3. And then I remember that I have to combine like terms if I have them. X squared, that's plus x, minus 6. Okay, and then I want to do that in that same idea on this one. I'm going to take my x and multiply it by the x squared minus 3x. And then I'm going to take my positive 1 and multiply that by x squared minus 3x. Okay? Then distributive property again. X times x squared is going to be x cubed. X times times negative 3x is negative 3x squared. And then 1 times this other thing is just going to be it again. So 1 times x squared is x squared. 1 times negative 3x is negative 3x. So combining my like terms, they're right in the middle here, negative 3x squared and, negative 3x squared and x squared. So minus 2x squared minus 3x. Okay. Now some people think that that's too difficult. That's too much work to look at distributing twice. So they've learned this method called FOIL, or I know that some people learn it as the eyebrow, nose, mouth, I guess. I don't really know how to do that, and it doesn't line up with the letters of FOIL in the right orders, so I usually don't talk about that one. But FOIL is an acronym. It stands for firsts, outsides, insides, lasts. I multiply my first two things together, then I multiply my outside two things together, and then my inside two things, and my last two things. Okay, the two things at the last of the parentheses. Okay, so let's try that. First, 4x times 3x is 12x squared. Outsides, let me switch colors. Outsides, 4x times 15, that's going to be 60x. For my insides, I have negative 6 times 3x. That's what I wanted to fix. So that's going to be negative 18x. And then for my last, I have negative 6 times positive 15, which is negative 90. Okay. Now I do have like terms here, just like before. And when I combine those like terms, I'll have my answer. So I got 12x squared. 60 minus 18 is 42. So it's a 42x. And that minus 90 just hangs around as well. So it is less work, but that same problem could have been done the same way up here. In fact, it really was. This idea of FOIL is just an expedited version of that, or it's just a little bit quicker way to do that. Now let's look at this next one. What does this actually mean? Squaring things. Well, that means multiplying something by itself. So I'm going to take this 2x plus 6 and multiply it by itself. So that's what the problem really looks like. It's not, one thing I want you to know, it's not 4x squared plus 36. Please, please, please understand that that's not what it is. Here's why. Let's look at our FOIL. 2x times 2x, 4x squared. Uh-oh, did he just lie to us? 2x times 6 is 12x. Sorry, I tried to fix it. Couldn't do it. 12x. 6 times 2x is 12x. And 6 times 6 is 36. So when I combine my like terms, I get 4x squared plus 24x plus 36. So people will answer as 4x squared plus 36 because they square this and then they square this and think that that's their answer, but it is not. Don't fall into that trap. This is the actual answer, and there's a huge difference between those two. Now, just to do these, and we'll try to do these a little bit quicker, if I have any bigger of one thing times another thing, I'm always going to have to use the distributive property, or at least some look at it. Here's what I do to try to cut down the number of steps, because back when we used distributive property up here, it looked like a lot, right? But here's what we did. We took the x squared and we multiplied it by everything in the second set of parentheses. So x squared times x to the fourth, use a little bit of exponent rules there, you get x to the sixth. X squared times 2x is going to be 2x to the third. And x squared times negative 5 will be minus 5x squared. Okay? So now I've done that. Now I'm going to take my next number and multiply it by everything in the second. The lines get a little bit crazy. You just have to go in order. 3x times x to the fourth will be 3x to the fifth. 3x times 2x will be 6x squared. And 3x times negative 5 will be minus 15x. Last thing to do, multiply the 1 by everything in the second set of parentheses. So really that just means copy down those things. X to the fourth plus 2x squared, plus 2x minus 5. Kind of bleeding over into the second problem, but that's okay. All right. Now when I get that, I just need to combine like terms, and it's just going to be a mad dash to combine like terms. I only have one x to the sixth. I only have one x to the fifth. Do I have any x to the fourths? Yes, I do. I have one of those. How about x to the third? I have one of those. So no combining like terms yet. X squareds, I do have two of those. I have negative 5 and positive 6. So that's going to be 1x squared. X's, I have two of them. I have negative 15 and positive 2. So it's going to be minus 13x. And then I only have one constant number of 5. So that's your answer. Nice and pretty, right? It's a little bit ugly, but it's doable. Okay? Go ahead and pause the video. Try the other two problems. Okay, hopefully you had a chance to get that done. What we should come up with on this. For the first step, I've just distributed my 3x into my second set of parentheses, as well as my 2 into my second set of parentheses. So I get 3x times 2x squared is 6x cubed, and then 9x squared, 3x, 4x squared, 6x, and negative 2. Combining like terms, I have like terms in my x squareds, as well as in my x's. Okay. And so that's what I come up with for an answer. The last one, it's very important that we know, what does x plus 1 cubed really mean? It means x plus 1 times x plus 1 times x plus 1. So from there you can kind of pick whatever you want to do. I chose to multiply the first two. And I used FOIL, first outsides, insides last, and that's okay. And when I combine like terms, I end up with this. X squared plus 2x plus 1, still times that other x plus 1. So at this point, I want to take all of the things in the first one, multiply it by everything in the second. So I'm multiplying those, I'm multiplying those, and I'm multiplying those, if you can track all that. When you get that done, you end up with x cubed plus x squared plus 2x squared plus 2x plus x plus 1. That turns into x cubed plus 3x squared plus 3x plus 1. A little bit tough, I know, but if you take it one step at a time, you can get the job done. Have fun. We'll see you in class.